Miami, AFP, fixing the balance of gut bacteria by introducing a specific kind of good bug could help treat Crohn's disease, a painful, inflammatory bowel condition that affects millions worldwide, researchers said Wednesday, November 15. Symptoms of Crohn's disease include frequent diarrhea, fever, cramping, fatigue, rectal bleeding and unexplained weight loss. The cause is unknown, and there is no cure. Some patients seek surgery or use medicine or supplements to ease the symptoms, which can appear at random. The report in the journal Science Translational Medicine calls for wiping out a significant portion of the bacteria in the gut microbiome, with the help of antibiotics. Then, bacteria that lacks a harmful enzyme known as urease, is introduced back into the gut so that symptoms can improve. So far, studies on mice and a small number of humans have shown promise in this approach, though more work is needed, study authors cautioned. Because it's a single enzyme that is involved in this process, it might be a targetable solution, said senior author, Gary Wu, Associate Chief for Research in the Division of Gastroenterology at the Perelman School of Medicine at the University of Pennsylvania. The idea would be that we could engineer the composition of the microbiota in some way that lacks this particular one. Researchers analyzed stool samples from 90 children with Crohn's disease, and compared them to 26 healthy children. They found an abundance of Proteobacteria in Crohn's patients. This bad Proteobacteria harbors the urease enzyme, which converts urea into ammonia, and fuels the intestinal imbalance in Crohn's disease, researchers said. So they turned to lab mice to look for ways to combat it. Previous research has shown that giving mice the antibiotics vancomycin and neomycin, along with an intestinal purging agent used before a colonoscopy, significantly reduced the bacterial load enough to create an opportunity for a newly introduced bacterial community to establish themselves, said the report. So researchers tried this gut purging approach in mice, and then introduced a single bacterial species, Escherichia coli. If the E. coli was negative for the enzyme urease, the mice's gut health improved. If the E. coli contained urease, mice experienced worsening intestinal inflammation and colitis. So far, researchers reported that 5 human subjects also underwent the antibiotic and colonoscopy prep, and saw their intestinal bacterial load reduced 100,000-fold. This suggests it might be possible to engineer the composition of the gut microbiota in patients with inflammatory bowel disease, said the study. A new study by Penn researchers in cooperation with the Children's Hospital of Philadelphia is underway to further examine this approach. Now that we can effectively reduce bacterial load in humans, it may now be possible to engineer the microbiota into a different configuration in a manner similar to what we have achieved in mice, Wu said. Although we're closer now, there is still more work to be done.